Well, hi, good morning. Thank you for joining me here. It's February 26th, and rainy yesterday a little bit. It's going to be a little bit rainy today, and things are melting good because there's a lot out there to melt. So now, what about this? So I read the comments that my video collected since I posted it yesterday. About 9 comments. Thank you very much. Very thoughtful. Everybody's right. And yes, I should do all those things. What's in my own mind here is it just a question of calibration being off? You know, if it was 10 or 20% off, I would think, yeah, you know what, let's just calibrate it again and see if we can get it there. But the calibration is way off. The result, rather, the GM result's way off. So I think something is out of sorts. There's lots of resistors in here. I like to ignore resistors as much as possible. And that's what I've been doing up until now, ignoring them as much as possible. It could be there's a resistor in here that's causing a problem. I don't understand the circuit well enough to even say. There's many resistors, but only 1 or 2 would be, I'm guessing, would be involved in any particular setup. So if you have low GM, then it would be the resistor related to GM testing, whatever resistor that might be, if there even is one. Talking about resistors and values, so this is what I've been using for the 2000 ohm resistor. Can you read? Yeah, 4K resistors here in parallel. I'm going to measure this and find out. You know, wire wound resistors are often very precise and very accurate. So let's take a look and see. I'm not having any effect here. First shorting, and now the resistors. Well, that's pretty close to 2000. I'm not going to get much closer from that. It's a touch off, but it's not way off. It's not enough to explain what's happening here, in my view. And would they have even been involved? Would the process that the calibration process involving these, is that even affecting this? I don't know offhand. Probably, but I don't know. Okay, so I think the next thing is to try to look at the circuit. Oh my God, no! Look at the circuit diagram and sort out if there's any particular resistor in it that might be responsible for what's going on. Let's take a look at the back here first, because again, I've been trying to ignore resistors. I like to pretend they're all good all the time. So just looking, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. These ones got coils. Yikes. This is not likely to be the problem. And down here, we have these whopper high wattage ones here, which are not likely to be off. Maybe some like this might be off. And then there's some precision ones in here. I think this is a precision. Yeah, you can see right on it says 1%. Now, I don't want to disconnect all these and test them. I like to test them in place. I like to know the value of them that I'm testing. Most of them look like most of them have got it written right on it nicely. So I should be able to just read it and test it. Now, which one of these is involved in the GM test? Okay, we're going to take a look at the schematic. Good luck. Okay, so my resistor hunting's not going all that well. I found a couple of resistors that are out a bit. I put little green flags on them. They're not out very much. This red one's interesting. This is a 1%. A lot of these are 1% resistors. And so is this one. It's supposed to be 133 and it measured, I can't remember now, 156 or something like that. The only resistor that I can find studying the schematic that's involved in the GM is this one. And this one measures correct. A lot of these are, like, did I say it already, are wire wound. There's really not much chance of them being out. But I have found something interesting, which is why I turned the camera on. These this row of high wattage resistors here. So I found all these on the schematic. These all measure correct. This one measures 50. This one measures 0.5. It says 50 on it. It shows 50. It should be 50. It's almost certainly because of some kind of switching thing. So I thought, well, I'll turn on the camera. We'll find out. So this one is supposed to be 50. You can see on my meter over there. I have a hard time making contact. There we are, 50.7. And then this one here, I gotta guess. I can't turn that any more sensitive. That it's simply because of some switch setting that this one is showing up low like that. So what setting would that be? That's a good question. I'm gonna look into that just before I guess it. I don't want to guess it. Okay, let's see if I can correct the situation here. So this is S3, and the resistor involved is connected to S3. S3 only has two positions. It's this EM, GM. It was on the EM. Okay, so we're going to take another measurement of this resistor. How can a wire wound high wattage resistor go low? I got no idea. So I'm sure it's going to be the switch. So we'll take the reading. So we're at 0. How do we get a 0 on there? Zero. Okay. I'm going to put some clip leads on this. That might be a better idea. Okay. To do this to get a stable reading. Okay, that's across. No, with these I'm not. Uh-oh. Well, I'm using two clip leads I don't normally use here. Let's go to square one. Deep breath. Well, don't like that. I keep my apparently defective clip leads in a pile, and then once in a while I go through the pile and resolder them or whatever it is. Really? You're both going to do this? It's a clip lead I've been using a fair bit. What has happened here? We're loose. We're loose down here. Well, this is pretty nutsy. I'm not the only one working on clip leads. Yeah. Meter's fed up with this. If the battery's going low in my meter, I wonder if that could cause it. Bad lead. Never had this meter act up at all like that. That's good. I stopped using this meter because it had become unreliable. Hey, I'm just where'd he go? Where'd he go? Where did he go? Did he jump out of here when I wasn't looking? I think that's the brother. Isn't that the brother? He must have jumped out and disappeared. Because if he was in behind there, I hear him. Oh my gosh, don't get stuck behind there. Well, I don't know what to do. So I'm going to go up and drink some coffee and ponder my sad situation with these meters. All of a sudden, the whole situation has kind of gone downhill. Don't jump up there. Oh, here's the other one. Here's the other one. Okay. Guys, look. Can you go somewhere else? Find somewhere else to play? No. Oh. And what, did he just discombobulate my computer there? No, I'm still going, still going. Here's what he did. Knocked this hard drive onto the floor and it pulled the cord out. Okay, well, while the destruction continues, I am going to go have some coffee and not worry too much about it. I mean, how much trouble can a cat really cause? Not really sure what's going on there. Why my meters were acting up. I don't know, some kind of solar blast from the sun coming through. Okay, look at that. So, don't know what was going on. Wait a minute. Let's just switch this down to here. When you're making low resistance readings, small resistances in your wires and stuff can add up. It can become significant. It's showing me, what's it showing me? Half an ohm. So if it's 50 here with half an ohm there, that's not that bad. That's not going to be a problem. Because I'm really not doing a precision test here. 0.7 again. Okay, good enough. I know what's going on. Let's hook up here. Be helpful if I could see something. One side of that resistor is just going to the chassis. Again, because it's a low resistance reading, and you need fairly good connections. Clip leads never all that good at such low resistances. Okay, question is, what happens when I flip the switch? Right now, what are we getting? We're getting a resistance here of almost 0, of 1 ohm, and it should be 50. Flip the switch. I think it's this one here. 26. Well, that's not 50. Oh, I don't want to study this circuit enough to understand it. I thought that would probably open the resistor. 26. That's half of 50. It's interesting. I wonder if they put these two 50s in parallel, and that's how we get that reading. I just can't believe that there's a problem with that resistor. Okay. The resistors I found that were out, and I certainly didn't test them all, are not out by very much. This one may be more important. Does this have something to do with the GM measurement? That's a good question. I doubt it, but I don't know. Let me look. Okay, don't know if I'm in any way heading in the right direction here, but I started with this resistor here, which is supposed to be 133 ohms, but measures higher. How much does it measure? Let's measure it again. It's supposed to be 133. It looks like 140 is the actual value. So 133, 1% of 133 is basically 1.3. So it's supposed to be basically no greater than 135. I got it up at 140. But what is it exactly? You notice the diode I replaced is right here, and I'm looking at the wrong resistor. I'm looking at the wrong resistor here. I'm looking at this one. This is the one I've been. Okay, let's check this one. So I'm saying wrong resistor. I'm looking in the schematic and getting and diagrams and getting mixed up here. I have no idea what this is supposed to be. This is a 5% resistor. So 9.8. About 10,000. About 10,000. I mean, it's in the circuit, so the test is questionable the whole time. $10,000 ohms. I wonder if, I changed out the diode, and I gotta wonder, is that part of the problem? This diode is directly affecting the meter. Perhaps this whole machine is working completely right, but the meter itself is not. Oh, that would cause lots of problems. That would cause lots of problems. So how do I know for sure? I mean, I think I put in a silicon here, and what I took out, I still have it here. Where did it go? I think I still have it here. So I'm going to find the original diode, and we're going to try to figure some things out about it. That's where I'm at. What a mess. I thought for sure I'd seen a parts list somewhere for this tube tester, but I cannot find it anywhere. I cannot find any reference to the diode that's in there, the diode I replaced. So I took a long shot here, and I asked Copilot, Microsoft's AI, what about it? Here's my question here. You probably already read this. I am working on a precise 3 tube tester, and there's one diode inside D1 that I need to know the type. Is it germanium or silicon? And his answer is, the precise 3 tube tester is a vintage piece of equipment. Finding specific details about its components can be a bit tricky. However, based on the era and typical design of such testers, it's likely the diode D1 is a germanium diode. Germanium diodes were commonly used in older electronic equipment due to their lower forward voltage drop compared to silicon diodes. Yes. If you want to be absolutely sure, you can test the diode using a multimeter. Germanium diodes typically have a forward voltage drop of 0.2, 0.3. Right. Well, I could have done that. I could have done that test. Okay, I will do that test. I don't even remember why I changed the diode anymore. So there's the original one from inside. It has a number on it. 1N54 is what it looks like, but I can't be absolutely sure that's the actual number. Okay, I'm actually just check into what a 1N54 is. Let's let this guy have a go at it. So, so UF 900 millivolts. That'd be forward voltage drop. Is that what that's reporting? 900 millivolts. So this is either a silicon diode or a really bad germanium diode. IR 4.2. Who's climbing up my leg here? 4.2 microamps. So that's probably the I reverse current in it. Well, that says it's a silicon diode. I probably did this when I changed it. I can't remember. It's so long ago when I started on this. What's going on here, buddy? What? Yeah, come on, show yourself. There he is. What, can you help me with this? First thing you did was sniff it. Well, I'll look this one up. 1N54 and see what it says. Maybe I'll get a picture of it. I can even compare it to it also. Okay, watch out here, cat. Everybody look out. Okay, here we go. What can you... Don't step on the keyboard, cat. I gotta hold them here. What can you tell me about a 1N54? One N54 series diode, general purpose silicon rectifiers, commonly used in power supplies, inverters, converters. Well, peak. Should give it. There we are. Maximum instantaneous forward voltage drop with 3 amps going through it, 1.2 volts. You know, it's just a silicon diode. There's nothing special about it here, I don't think. Maximum RMS voltage. Maximum repetitive peak reverse voltage. The VRRM 50 to 1,000. Oh, that's not very good. Yeah, I'm getting nowhere here. I'm getting absolutely nowhere. Oh my gosh, cat, you just go down there. There we are once again. Show them off, buddy, because you're not going to have them too much longer. And you don't even know that, do you? Okay, I gotta stop here. I am totally flummoxed. Flummoxed would be the word. I guess I got myself into quite a corner here. If I wasn't making videos, then it would just be me and my time kind of being spent on this. And what I'm talking about is abandoning this project. I'm not going to abandon the project, don't get me wrong, I'm just talking about it here. But because not only have I committed a lot of time to this, and it's probably one problem away from working fine, whatever that problem might be. I also know you who have been watching all these videos have invested your time into this too. And then to make it even worse, one of you just sent me 20 bucks. Now I can't quit. Now I cannot quit. I have to see this thing through. Huh. Yeah. That's right. I don't know what to do next. What am I going to do next? What can I try? Well, try testing on. Why not just, for crying out loud, let's test some tubes. Yeah, let's test some tubes with this thing. Because, you know, maybe I'm chasing smoke. I do that from time to time. I get convinced that there's a problem. I go off troubleshooting along, and then eventually, hey, there never was a problem here. It was just all in my head. Now, I've tried to make sure that that isn't the case here, because I've tested a number of tubes. Two tubes. I've tested them in multiple tube testers, so I'm pretty sure of the condition of the tubes I'm testing. So I'm pretty sure what the results should be coming from here. But let's do some more. Now I've got a whole bunch of 6L6s. And you know what? I also have a chart from each of the 6L6s being tested on 2 other testers. So why don't I run through these? Maybe I'll just fill out a column right here and write the result from this tester for each of these tubes. How is this going to help? I got no idea. I don't think it's going to help. I think it's just going to provide even more evidence that there's a problem here. But let me do that. Gee, I just hope there isn't a wiring issue inside here somewhere. Yikes. I'm looking over the instructions for building this. Ooh, wow! It's not a Heath kit. Heath kits, the instructions are fantastic in a Heath kit. In this thing, the instructions would require an awful lot of care to carry out without making a mistake. A lot. So maybe there is a mistake in here. Maybe this has never worked right. It did seem to work right on the EM test. Well, we're going to start with the same tube I've been testing all this time. So I'm going to set up the tube tester, and we're going to run through a bunch of these quickly. Okay, here we go. So I have this set now for a 6L6, and for sure 6.3. Away we go. So I have quite a few of these tubes here to test it. Every one of them looks different too. They're all a little bit of a different variation on the glass bulb or something like that. Okay, let's read the current flow through the tube first. According to my meter, we're a little over 3 amps. Let me check for the line here. I should really do that first. Okay, so the line is closed. Bias is supposed to be 4.8. Way up. 2.9. I better look. I cannot trust my memory at all. 2.9. 2.9. And it happens to be at 2.9 on the 10 volt scale. 2.9 on the 10 volt scale. That would bring it up to about here. Okay, check the line. Not bad. Okay, and we wanted to read the tube current. It says 0.8 here, or 0.83. That's pretty close to 0.9, so I think this probably is 0.9. It'd be interesting to compare these different tubes just with this test, just the heater test. So, I gotta write this down. I'm not going to make you watch all this. I make you watch this one, and then I'll perform it for all these guys, and then we'll look at the results. So this is number 2. So I'm going to write down the current appears to have gone up. Is it current? Current. Appears to have gone up. Line check. Line is the same. Bias is way off. What happened? What happened there? Didn't I set this? Oh, 2.9. Jim. I got this 4.8 number stuck in my head. It was probably just fine. That's 2.9 on the 10 scale. Read the current again. So I get 0.8 on the meter. So I'm going to write, this is number 2, 0.8. And then the actual test. There we go. So reading on the 20K scale, 4,100. It would be 4,100. I'm going to write 4,100 here. The reject for this one is 1385, I believe. No, that can't be right at all. That can't be right. I don't know what are all these numbers. There it is. Reject is 1300. Reject is 1300. 4100. Wow. What's going on here? Precise 1300. Oh, you know, this is probably for the 6C4. Yeah, that's probably what that is. Okay, carrying on. So there we go. That's what it's going to look like as I do the rest of these tubes. So, okay, do I dare grab that? Not with my bare hand, that's for sure. Okay, I'm going to test them all, and we'll see what we get. Okay, I've done 5 tubes. I thought there were 6, there were only 5. So let's take a look at the 2 testers that I find reliable and compare the results for these different tubes. 2, 3, 4, 5, and number 6. There is no number 1. So we're looking at the 2 testers in these 2 columns here. This is the GM reported by the 2 testers. So just compare them. 6,000 versus 52, 4,800 versus 52. You got to wonder, like, how can that happen? 5,100 versus 48, 57 versus 5,000, 6,000 versus 5,000. So you got 6,000 here, 5,000, 6,000 here, but 5,200 there. So there's a lot of variation in the test, and it could be, I don't know. It could be, I don't know. So even with my reliable testers, there is some variation. And these numbers cannot be compared directly, but the ratio of them should remain relatively the same. So if this guy's testing higher like it is here, it should be testing higher all the way down, but it's not here. So I probably did something wrong. Okay, let's look at the results from here. First, we'll look at the current results. This is the filament current results here. So 0.8, 0.9, 1.05, 0.88, 0.95. The proper current, or the book current, is 0.9. Accuracy of the meter and all that, is this really 0.9? I did my best, so let's assume it is really 0.9. So there's a bit of a variation here, all the way from 0.8, which is quite low. This is the tube I've been doing all the testing on too, to a high of 105. Is a variation just a normal variation of these tubes as they come out of the factory, or yeah, I don't think so. I think these things would come out of the factory pretty close to what the factory claim is. I don't know though. I got no experience at testing current flow in these tubes. As the tube gets older, would the current flow be different? Well, I suppose the heating element could rise in resistance, and then from its normal resistance, and you would get a lower current. So it doesn't explain the 1.05 very well. Okay, so looking at the GM results, the first thing that strikes me is they're all pretty similar: 4,100, 4,200, 4,100, 4,000, except for this one, 3,600. And this one, as I just left the test on it, I think it's this tube right now. Yeah, tube number 5. This was dropping. So I wrote down 3,600. At this point, yeah, you could say 3,600 for that. Yeah, you could. So we would compare 3,600 to 5,000 to 5,700. All these are low. The reject point over here, as I have it on my screen here. Just hang on a sec. Let me make sure I get it right. 6L6. The reject point 3825. Don't they have that written here somewhere? 3825. So that means, according to this tester, these tubes are all passing except for this one. And what's the problem with this one? This is the one that's in there right now. It's a low current. And it was dropping. Let's take a look at this one a little further, because it's right in the machine and it's been on for a while now. So that should mean it's really fully warmed up. And one of the things I noticed in watching the filament current, it takes longer for these tubes to settle down than you might realize, than I've realized. I usually give them 15 to 30 seconds. I figure they're pretty much done. But even a minute later, this thing is still showing a drop in the filament current. Okay, let's take a look. We'll see. Whoop, whoop, whoop. Take that off there. Put this on here. So I'm looking up here now on the 3 amp scale, and this is reading 0.86 or something like that. 0.86. And look at this, 5.88. So it's the same reading. It's not dropping anymore. Okay, so we'll do the test. Let's check the line first, because you're probably wondering. The line is right on, and the bias is set right on 2.9. It's very stable. Test again, and we can see it's 4,000 dropping. So it was 4,000. Now it's be 39. It'd be 30, 38 pretty soon, which is right on the reject point. How come this guy tested so good in the other testers? So I have my other testers set up in another room, so I'm going to run it and repeat number 5 in the other 2 testers and come back and find out. You see, the thing about having a lot of tube testers is you'll never know if the tube is any good or not. You'll never ever know. Okay, that's what I'm going to do here. Okay, so the two other tube testers that I'm relying on for comparing to this one, neither one of those have made it in here yet for a check of their calibration. So it's possible those guys are out of calibration, although I do rely on them. And again, I'm usually doing just, yes, this tube is good, no, this tube is dead, you know, that kind of testing. I'm not really too concerned about the actual readings or comparing or anything like that, but here we go. So tube number 5. Okay, these two penciled results. I should have written this one. Oh, did I do something wrong here? I'm asking you if I did something wrong here. I read this directly off the scale. I didn't read it in double to get this. What happened there? I'll have to go look at that again. Yeah, there's something weird. But anyway, assuming these are correct, bad assumption. 5,300, previously 5,000. Somehow it got better. I don't know how. Over here, 1,900 previously, 2,000 this time around. 2,000 translates to a 6,000 GM reading. This is a 5,300 GM reading. 3,600 GM reading from this guy here. I gotta go see what did I do here. I gotta go check that. Maybe man alive, you know, the more of this you do, I get like there's a lot of room for making mistakes. That's what I want to say when you're doing this tube tester stuff. A lot of room for me to make mistakes, that's for sure. Okay, I see my mistake here. It's really not a mistake. When I was doing the test on the 966, I was just writing down the number from the wrong scale. So the correct scale is a different scale, double this. So I just doubled it, and that's what this number is. So these are the valid GM measurements then. Just looking one last time. 2001 tester. I'm sorry, 6001 tester, 5300 in another tester, 3600 in this one. The fail point in this tester is 1300 compared to this number. So wow, big pass here. This one would be somewhere between 3150 to throw it away, or 5,000 it's brand new. It's better than brand new. How can that be? Oh, can that really? Excuse me. Can that really be? And this one, 3,600 and 3,800 is the reject. So this is again, this is a throw it away, or it's right on the line more or less. So pretty good, not good. That's what these testers are saying. Okay, that's it for me today, because it's after lunch already. Oh my gosh. Have a great day.